Alrighty, folks, welcome back. So we are continuing graphing this function that we started yesterday, or not yesterday, in the previous video. Blech. Okay, so just a reminder, the original function was right here, up in the top left. We have a cubic over a quartic, and what we did is we factored it to really make it easier to find all these different pieces here on the left side. So we found the y-intercept. That one's not so bad. Just plug in 0 for x. X-intercepts, we found that by seeing what values make the numerator equal to 0. In this case, there's only 1. Our removal of discontinuities, just like before we started talking about all this factoring business, was we're trying to find when we have a 0 over 0 situation. That happens twice in this function. Our vertical asymptotes are when we have a not 0 in the numerator and a 0 in the denominator. Happens twice. And in this case, our horizontal asymptote is at y equals 0. And we know that because when we plug in bigger and bigger x values, that numerator is getting way bigger than the denominator. Sorry, vice versa. The denominator is getting way bigger than the numerator. Okay, so what I've done is I've just taken all that information and plugged that in. And so what this is, all this information here in this table here, just makes a sort of skeleton, I suppose, of our function. Okay, so what is our function actually going to look like? Well, as you can see, our function is actually going to exist in 3 pieces. So how do I know that? Well, when we plug in when we draw in our vertical asymptotes, our function is broken up into a piece here on the left side, a piece here in the middle, and a piece here on the right side. Did I say left before? I meant left. I think I might have said right, middle, right. We have in 3 pieces. Again, why is this? Well, this is because our graph can't cross over the horizontal asymptote. Sorry, the vertical asymptote. Our graph is not going to look like this. This doesn't happen because, again, you can't plug in x equals -2 right here. Okay, so the question is, what happens on either side? This is where the information that we plugged in, the information that we found before actually really helps. You might have caught, well, if the vertical asymptotes kind of split up our graph, what about the removable discontinuities? Remember that the removable discontinuities don't actually affect the shape of the graph. They simply are just plucked out of the graph. They don't have any drastic effect, not like a vertical asymptote does. Okay, so where do we even begin? Well, we actually can start with the removable discontinuities here. So what's going on? I'm going to start on this side over here. Okay? Now, our graph has the point 5, 11 over 28 plucked out of it. What that means is that whatever the graph kind of would be normally, if you remember from the last video, I called that kind of the simplified version, like r prime of x. It would look just like that, except again, that point is just erased. But since that point is there, we can actually confirm that this graph is going to look like this on this side here. Okay, Mr. Yang, how the heck am I supposed to figure that out? Well, this is where we get back to, looking at these pieces. And I'm going to start off with this horizontal asymptote business. Remember, horizontal asymptote means when x is getting really, 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 really big, in the positive sense, in this case, what happens to the y value? The horizontal asymptote says that the y value is getting closer to 0. And so the graph is supposed to kind of come from this point, and as it goes further along to the right, it's going to get smaller and smaller, but never actually hitting 0, remember. And we know it's not going to hit 0 because there is no x-intercept on that side. The only x-intercept in this graph is at 1/2, 0, which is right here. Okay, so we know what's happening actually on the positive end, if you could say that there's an end, which you really can't. As we get further and further over here, our graph is getting closer and closer to the x-axis. Okay, but what happens if I go from that point and go off to the left? Well, it couldn't possibly happen this way. It could not possibly do this. Again, because if it did, it would have another x-intercept, but it doesn't. We've already checked that. And the only possible option here is to as we get closer and closer to that vertical asymptote, is to as it's getting kind of steered away from it, and it's got to go somewhere, so it's going to end up going up and up and up like that forever. So as it gets closer and closer to x equals 1, it's getting closer and closer to positive infinity here. Okay. Again, the graph couldn't possibly do this because that would mean it has another x-intercept, which it doesn't. Okay. We can use a similar line of reasoning on the left side here. So I'm looking over here now. All right. Well, again, this point is kind of think of the removable discontinuity as a starting point. And by the way, if there was no removable discontinuity here, just plug in a point over here and see what the value is. So for example, I could just plug in -10 and see what happens. Okay, so this graph, again, well, as it goes to negative infinity, it's getting closer and closer to 0. And so as I go farther and farther to the left, it's going to arc. That's really bad. It's going to curve. It's going to go curve and kind of arc like so. And I guess I should draw arrows here. Okay. Now, it is possible, actually, for a graph to do this. I'll draw it in red. It is red. It is possible for a graph to do this and then kind of level off from infinity from the top side. We know that this graph does not, once again, because that would mean it has another x-intercept, which it doesn't. So that's why all this information is actually really cool. It's like a little puzzle. Actually, it pretty much is a puzzle. And once again, the graph couldn't turn around and start going upward because it only has one x-intercept. I'm going to keep saying that over and over. So the only thing that it could happen is that as we go closer and closer to this vertical asymptote, is to go further and further downward toward negative infinity. And we're going to do a similar thing in the middle now. The last piece here is what's going on in here. Well these two pieces got to connect somehow, so it's going to connect like that. Excuse me. And then once again, well, this can either do this or it could go like that. It has to go downward though, because again, there's only one x-intercept. And so as it gets closer and closer this way, it will go like that. And the reverse on the left side. So from that x-intercept, we're going to have to go up like so. And that's the shape of the graph. So really, the first step to graphing these rational functions is finding all this information. Once you have this, it's just a little bit of logic to see what is actually going on, right? So there are, of course, going to be more complicated examples, but hopefully this helps you in terms of, finding those important pieces and putting those pieces together into this puzzle shape. Alrighty? We might do one more example, or maybe I'll just find one and borrow one from someone. But hopefully that helped, and I'll see you in the next video.